That when you have a alkyl halide, suppose we have this ethyl bromide. When you treat it with KCN, you get cyanide. When you treat it with the AgCN, you get isocyanide. First, analyze the product. In this product, this is cyanide. This is isocyanide. See the new bond formed. Here, this bond is formed, new. That carbon-carbon bond is formed. Here, this bond is formed, means carbon-nitrogen bond is formed as a new bond. Now, why it is so? Why the different products are formed? The reason is that when we add KCN, or you can also add NaCN, the same. This KCN is ionic. This AgCN is covalent. Then what happened? If it is so, then this CN, if it is ionic, it exists in the form of ions. And this is the structure of cyanide ion. This is a type of ambident nucleophile. Ambident nucleophile means it has two centers to attack. It can attack through carbon, it can attack through nitrogen. इसका ये वाला कार्बन वो भी न्यूक्लियोफिलिक है, that can attack on this carbon because this is positive, and this nitrogen can also attack. Any species which can attack through more than one atom is called ambident nucleophile. Like OH negative ion cannot do like this. You can see here. OH negative ion can attack only through the oxygen, not through hydrogen. So only one atom is there, that is a nucleophilic atom, oxygen. But in this case, there are two atoms through which it can attack. When this is silver is a covalent, it means there is no ions. So it exists like this, AgCN. There is only nitrogen which can attack. So when the nitrogen is there, then this nitrogen attack on this carbon, Br is removed to get the product. That's easy. New bond formed is between the carbon and the nitrogen. Carbon has no tendency to attack because it is attached with the silver. It do not have a negative charge. Now here when we have a KCN, it dissociates to form ions, and Cn negative ion, in Cn negative ion we can see that carbon has a negative charge that can attack, nitrogen has a lone pair that can attack. Two possibilities are there. But as you know that carbon-carbon bond is more stable than carbon-nitrogen bond. So when carbon-carbon bond is more stable than carbon-nitrogen bond, it means this nucleophile attacked through the carbon. When it attacked through the carbon, new bond formed will be carbon-carbon single bond and product form will be cyanide. So this is the explanation of this question. This is also a question there in NCERT, that haloalkanes when it reacts with you can say KCN or NaCN it gives cyanide, but when it reacts with silver cyanide it gives isocyanide. Why? So to write the answer of this question, first you have to write that KCN is ionic in nature, so it dissociates to give ions, and Cn negative ion is ambident nucleophile which has it can attack two ways to this alkyl halide. But AgCN is covalent, no ion are formed, so only nitrogen is a lone pair, through lone pair can attack on alkyl halide. So when ambident nucleophile is there, so carbon preferably attack that ambident nucleophile attack preferably through carbon because carbon-carbon bond is more stable than carbon-nitrogen bond. Okay. Next is substitution by nitro group, formation of nitrolicane. So in this reaction, when we take some alkyl halide and treating it with AgNO2, silver nitrite. Okay, this is your silver nitrite. Can be written like this: AgO and double bond O. Then you get when you heat it, you get RNO2. This is your nitrolicane plus AgX. This can be written like this: Rn. It's nitrophene. Now from this reaction, and I will write one example here. Like if we have ethyl bromide treated with AgNO2, you heat, you get this product. This is your nitroethane. See which bond is formed. New bond formed is between the carbon and nitrogen. This is new bond. Same reaction is like if we 7 substitution by nitrite group. Formation of alkyl nitrites. What happened in this reaction is when you take some alkyl halide and treat it with potassium nitrite or sodium nitrite, KNO2 or NaNO2, then you get nitrite product like RONO plus KX. So let's take one example. Suppose we start with ethyl bromide treating with KNO2 to form CH3 CH2 ONO plus KBr. Now see here, which is new bond formed? That is between C and O, and here is between C and N. This is the difference. When you change this reactant or this reagent, your product will change, just like cyanide and isocyanide. So its explanation. Here the nitrate like NO2 is again an ambident nucleophile. So again I will be writing the reactions in a summary form. Next, suppose we have CH3 CH2 Br. When you add in AgNO2, you will get this. When you add in KNO2, you will get this. Difference is again KNO2 is ionic, dissociate into ion, K positive, NO2 negative. NO2 negative is written like this: Again here, this is again ambient nucleophile. It can attack through nitrogen, it can attack through oxygen. So preferably it will attack through oxygen here because CO bond is more stable than NO bond. Okay? So it will attack through this oxygen. Here, Br is removed like this. What happened in case of AgNO3, like AgNO2, is covalent. Okay, it's covalent. Its structure will be like this. Now, here is only one atom which can donate its pair of electrons, that is nitrogen. So this is a nucleophilic center. It will attack here to produce this. So this is the reason why when we take alkali nitrides like KNO2 or NaNO2, we get nitrides, or you can say alkyl nitrides, and when you react with the silver nitride, you get a nitro compound. Next is reaction number 8, substitution by alkyl group formation of higher alkynes. See an example. First, if we take some terminal alkyne and adding some base to it, sodamide, NaNO2 is called sodamide. It will act as a base. This hydrogen and this hydrogen, because this carbon is sp hybridized. This carbon is also sp hybridized. So this hydrogen is acidic. This is also acidic. So base will abstract the acidic hydrogen to produce a salt. If you put here R, or leave it, put here R. So there is one acidic hydrogen. Do like this. So this hydrogen will be abstracted by the base to get R, C negative, and Na positive. And ammonia get removed because this NH2, this part is a base. It will take out this hydrogen and this will shift to carbon. So now when further you treat this molecule with some alkyl halides, say R-X plus RC triple bond C negative and A positive. So this is nucleophile. Now this portion of the molecule is nucleophile. It will add to this axis removed. So to get is R C triple bond C R dash plus NaX. In this way you can prepare the higher alkynes. Like suppose I start with methyl amide, adding to CH3 C triple bond C Na. What to get this? This is alkyne with 3 carbon. Now this nucleophile attack on this, you get the product alkyne with 4 carbon. So it is CH3 C triple bond C CH3. So now you get a 4 carbon alkyne. In this way you can prepare the higher alkynes by using this method. Okay. Next substitution reaction 9. Substitution by hydrosulfide group. Formation of thiol poles. Like we have on this. So it is RSH. Sorry, NaSH. Sodium salt. NaSR in Lexicon. This is positive, this is negative. Which part is nucleophile now? Your SH negative nucleophile. Tag on R, X is removed. So we get R, SH. This is thiol pole. Alcohol is ROH, thiol pole is RSH. Okay, simple. So we start with the ethyl bromide, treating it with the NaSH. This is positive, this is negative. So you get ethane thiol. This is your ethane thiol. Next is section number 10, substitution by mercaptide group. Mercaptide group, formation of thiol ether. So when you treat, like, just replace this H by R, RX, NaSR dash. So this is positive, negative, this is positive. So your nucleophile here is S with the chiral group. X is removed. Next productive form is R, S, R dash. So this is thiol ether. It is also called mercaptide. Okay, mercaptide is NaSR. सोडियम जैसे लाइक इसको क्या बोलेंगे, इसको बोलेंगे सोडियम mercaptide. If we write the example like Ca3CH2Cl and adding here Na sodium, then SCH2CH3, this part is negative, this part is all negative attack on this to produce CH3CH2S, CH2CH3 NaCl. So this is your sodium ethyl mercaptide to produce a thiol ether. Next, amethyst. Substitution by amino group. Formation of amines. Like this is called Hoffman ammonolysis reaction. We start with the ethyl bromide. Treating it with the ammonia. It is nucleophile now. This tag on here, HBr is removed. Primary amine is formed. Primary amine further. This is your 1 degree amine. It may change into standard amine by treating again with this alkyl bromide. Okay, when you take this, suppose. Now adding this primary amine. Again it is a nucleophile. Move HBr to produce this is here 2 degree amine. This may change into 3 degree also when we add one more molecule of this. Okay. So this molecule, this again change into 3 degree. 3 degree में क्या आ जाएगा? CH3, CH2 thrice, and this is again, this is still the nucleophile. When you add one more molecule to this, say CH3, CH2Br, again it's a nucleophile. It will give you CH3, CH2, 4 and positive Br negative. This is quaternary, you can see tetraethyl ammonium bromide, quaternary ammonium salt, 4 degree. So this is the reaction with the ammonia. So these are the some nucleophilic substitution reactions of alkyl halide.